In this video, we will take a look at the new input system in Unity. I will explain it in detail what functionalities does it have and how you can use it in your own game. In the starting project there are a wizard and a plane, but we can't do anything with them. By the end of the video, the wizard can run left and right, she can jump and can enter the plane. After that she can fly around with the plane and exit it when she wants. So let's get started. First you have to install the input system package. Go to Window, Package Manager and search for input system. Click Install and then restart Unity. Once restarted, go to Project Settings, Player, and here you can see we are now using the new input system instead of the old one. You can select both of them if you want to, but now I will just leave that as it is. To get started, we have to create a new InputActions asset, and let's name it for example Player Controls. If we click on it, a new window will be opened where we can set all the inputs we need. The window consists of three parts: Action Maps, Actions, and Properties. An action map is basically a set of actions that the player can do at a given time. An action is one thing the player can do. For example, he can move, jump, shoot, and so on. Each of these is an action. In the properties we can do some configurations and modifications for the actions. We will see this later in more detail. So let's create the action maps. Now we need two of them because the player can be in two different states. He can either control the wizard or control the plane. Both of these has completely different actions. For example, with the plane we can jump, or when we're controlling the wizard we can go upwards and downwards. Next, create the actions. When controlling the wizard we can move, jump, or enter the plane, so we need these three actions. When controlling the plane we have only two actions. We can either move the plane or we can exit it. Now we created the actions, so we decided which actions can be triggered by the player, but we haven't set up any keys for them, so let's see how we can do that. As you can see, each action has a little drop down where we can add bindings. We can add multiple bindings to a single action, in which case multiple keys will trigger the same action. For each action we can select the action type. We will use the first two since the pass-through is useful only if we want to handle input from multiple devices at the same time. The button represents a single press, so use it when the action should be triggered each time you press a button. Such cases can be jumping, attacking, opening a door, and so on. Use the value if you need to handle the input continuously. This can be used for moving the player or turning the car in a racing game since we need a value from -1 to 1 that tells which way we want to rotate the car. Start with the jump, which is the easiest. The action type is button since we only need to be notified when the player presses the jump button. Click here where it says no binding and here we can bind the key to this action. You can go here and search the key yourself, but it is very time consuming, so I will just press listen and press the spacebar on my keyboard and it shows up here so I can select it easily. The enter plane action is very similar, just choose another key, let's say E. However, for the movement we need to set the action type to value, and from the control type list select axis because we can move along with a single axis, so basically left and right. Now delete this single binding because we need a 1D axis composite instead, so create that. Let's call it arrow keys. Here we need to select two bindings, the positive and the negative. For the positive select the right arrow and for the negative select the left arrow. If we press the right arrow the value will be 1, and if we press the left arrow the value will be -1. We can add another composite so we can also control the wizard via the A and D keys. Add. For the plane we have two actions. The move action will have an action type of value, but this time we will select vector 2 because we can move the plane in two directions, so left, right, up and down, not just left and right. For the binding, add a 2D vector composite and set the up, down, left and right bindings. And we can also add the 2D vector composite for the VESD case too. Exiting the plane is pretty simple, just select a button, for example the escape and Q buttons, so we can exit the plane by pressing either of them. Let's check out how the interactions work. Let's say we want to allow entering the plane only if the player holds the button for a longer time and not just presses it for a moment. Select the enter plane action and add a new interaction. Here you can see we have several options. We need the one which says hold. Here we can also configure how long the player has to hold the button before the action is triggered. Now we have bound all actions to a key on the keyboard. Let's see how we can allow the player to control the game with another device, like a game controller. For this, let's create a control scheme which is helpful for us to organize different input devices. Click in the upper left corner, Add Control Scheme. We can enter the name and select an input device, which is keyboard for now. Now for all bindings we can select which control scheme it belongs to. So go through all of them and select keyboard. Now we can create another control scheme for gamepads. We can select a specific one like PS4 or Xbox controller, but it's recommended to go with the generic one. Now all the bindings have disappeared, but don't worry, they are just playing hide and seek. They just belong to another control scheme which can be switched here and you can see them again. Now we can bind the gamepad button for every action as we've done for the keyboard. I'm using an Xbox controller, so I can either select the A button, but that would work only for the Xbox controller, so I go with the button south, which means the A button for the Xbox and X button for the PS4 controller, and so on. Setting up the other actions is similar to the keyboard, except for the movement of the plane. Here, instead of the 2D vector composite, we can add a simple binding, because the gamepad stick can be moved in 2 dimensions, so it will generate a 2D vector output in itself, so we can use this as a simple binding. Now we are finished with setting up the whole input system, we just need to tell what should happen when an action is triggered. Before we close this window, make sure it has been saved by either clicking on the autosave button or the save asset button manually. Now select the wizard and add the player input component to her. Here we have to assign our player controls asset. We can select the default scheme, but if we leave it on any, Unity will automatically detect our input device and switch between them when needed. We can also select which action map should be the default one. Since we are initially will control the wizard should be the default one. We will change it through code when needed. Here we can select how we want to get notified whenever an action has been triggered. We will use the one which says invoke Unity events. I think this is the easiest one and the most logical, at least for me. Now we have a drop down for the events, so we can set here which functions should be called when a given action is triggered. It is the same system as in UI buttons, for example. Before we can select these functions, we have to create them, so create a new script called PlayerInputHandler, which will be responsible for handling the player inputs. So here we need a function for each action. As you can see, these functions should expect one parameter of type callback context. So let's create our 5 functions: onPlayer movement, onPlayer jump, onEnter plane, onPlane movement, and onExit plane. Attach our new PlayerInputHandler script to the same game object and set the events. Drag the script into here, select PlayerInputHandler, and here we have onPlayer movement. Do the same for all the other actions. Now let's get back to the script and just print out something to the console in the onPlayerJump method to see if it works so far. And now if I press the spacebar, the jump message will appear in the console. It also works with the A button on my Xbox controller. But for some reason, every time I press the corresponding button, the message will appear 3 times, so the function will be called 3 times for each button press. Each action has 3 states. We can check what states we are in through the context parameter. The started property will be true if we started to press the button, the perform will be true if the action is performed, and the cancel will be true when we release the button. So check if the performed is true, and print out the message only then. And now the message only shows up once for each button press. Now we need to implement all of these functions, but I like to organize my scripts well, so I will create another script which will be responsible for controlling the player and everything related to the player. And this current script will be responsible for the input handling only, so it will call the other scripts method whenever it's needed. This way, if we need to change the player logic, we don't need to touch this script, and vice versa. So create a new script called PlayerController. I will just quickly write the functionalities of this class. This will be a very simple and not perfect player controller just for demonstration purposes. The only important thing in this script for this video is how the movement is implemented. I store the current input in the current movement field and I modify the player's or plane's position in the update method based on this value. We will see why it is implemented like this in a moment. Now the player controller is finished, so let's finish the player input handler as well. First we need a reference to the player controller to access its functions. In the onPlayerJump function, if the action is performed, we have to call the controller.jump method. Let's try it out, so assign all references in the inspector, and as you can see, now the jumping works. Do the same for entering and exiting the plane. When performing the enter plane action, we are entering the plane, and when performing the exit plane action, we are exiting the plane. The player movement works a bit differently. It is a continuous value between -1 and 1, so not a simple true-false value. First we need to read this value from the context parameter, and then we can use it as we want, so I will pass it to the player controller setMovement function, which expects a vector2 parameter, so first I need to convert it. Very important note that this onPlayer movement function will be called only when the input value is changed. So if I press the right button and hold it for 10 seconds, this function will be called only once, and not in every frame. This is why I need to store this value in a field, and that's how I can use it in every frame in the update method. When I release the right button, the onPlayer movement function will be called again with a value of 0, so then I set the current movement value to 0, so the wizard will stop running. The plane movement is very similar, but remember that we use a vector2 input here because we can move along 2 axes, so we need to read a vector2 value. Let's see if the game's working. I can move and jump with the wizard. I can enter the plane by holding the button. If I'm too far from the plane, it says I cannot enter, but when I move here and try again, it works properly. Now let's see the plane movement. And it's also working. I can go left and right. But wait, I can't go up and down. Why is that? We are currently using the wizard action map, so we can only use the actions which are on this action map. The plane movement, however, is on the other action map, so we need to switch to that action map whenever we enter the plane. If I go back to the player controller class, you can see that the enterPlane method returns a bool value, which is true if the entering was successful and false if it wasn't. We only want to change action maps if it was successful, so we have to check its return value. In order to switch the action map, we need a reference to the PlayerInput component, and here we say PlayerInput.switchCurrentActionMap and pass the action map's name as a parameter. We could also make a constant out of these, so it would decrease the chance of typos, but I leave it as is for now. The same for exiting the plane. If the exiting was successful, we have to switch back to the wizard action map. Currently, the exit plane always returns true, but the game logic could change, so it's better doing it this way. Now I can enter the plane, I can go in all directions, and the exiting also works fine. Just a little thing, but maybe I found a bug. Or it's a feature, I don't know. After I exited the plane and want to enter again, I have to press the entering button 2 times, because after the first one, nothing happens. I'm not sure why this is happening. I think that is because we switch action maps in the perform state and the cancel comes after that, and maybe that causes the confusion. So let's put the action map switching on the cancel state instead. For this we will create a bool member which stores if we are currently trying to enter the plane. So if the action is performed, we enter the plane, even if the player is still holding the button, and store the result of the function in our newly created member. Then if we are in the cancel state and the entering was successful, we can now change the action map, and of course we are not trying to enter the plane anymore. We can leave the onExit plane as it is. This behavior only appears when the hold interaction is active, so the exiting is fine because that is just a simple press. And now this also works perfectly. However, if I use my controller and release the stick suddenly, the controller gives a negative value for a moment, so the player will flip because of that. We can create a dead zone for preventing such behaviors. Just go back to the player controls asset and select the left stick, add the preprocessor and select Exit Dead Zone. And now if we move the stick with less than 0.125, it will be counted as 0, so basically it will be ignored. Now it's much better, but not always, so we can enter a higher value, like 0.2, and now it's working perfectly. This is amazing news, because this means we can now enter the plane, go upwards, and jump out of the plane, jump through this gap, and now this other Unity tutorial has been unlocked for us. So let's meet there.